I'm gonna resume recording, and we'll see what comes in. So what do you think? You think there'll be a when do you think your next trade show will be? When do you think you'll go to the next trade show?
Well, that's a good question. PAC Expo is what, in November?
Sounds right.
Yeah, I don't know. I don't know what's going to happen here.
I don't either. How about like FISA?
Yeah, I wouldn't think that we're going to be doing any social gatherings probably throughout the rest of this year.
Probably not. I agree.
You know.
Yeah. So we got some people filtering in. I want to thank everyone for attending. Deb, Tracy, good to see you on. I have here what do I got? I have the Phase 3 cream, I think it's pronounced, but this is one of you probably can't see it on the camera, but it's one of my favorites. I'm looking forward to it. Leon, you got anything, or are you abstaining?
Oh no, you gonna invite me to the party and not make you drink? Are you crazy? So this is this one is a Fremont Fremont IPA. So it's a new one for me. I never had it. I have had the Fremont other beers, but this is new. I don't know if you're familiar with the Seattle area then, right?
Yeah, I was actually going to say, one of the first craft beers I ever had, I was, I don't know, maybe 18, 19 years old. My grandmother used to live in Sammamish as well, and I would go out and see her, and she was kind of old school. She'd let me have a couple, and I had it was Full Sail Brewing's Session Lager. That was one of the first craft beers I ever had, and I loved it. I couldn't figure out, at the time I was just young. I didn't know anything about beer. I still really don't, but it was crazy to me how crisp and fresh it was. So anytime I get out west, I always try to get Full Sail. Any of the Full Sail stuff. Their whole Session line is awesome, and yeah, it was that's some of my favorite stuff out there. But you guys have a ton of great beers.
There's a lot of good beer. There's a lot of good beer all over the place. But unfortunately, there's going to be a lot of good beer breweries that aren't going to weather this storm. So,
that's really interesting. You're right. And one of the customers, one of the webinars we did a few weeks ago was on beer pumps, craft beer pumps. And we had the guy who did it with me was a gentleman named James Moriarty. James worked at a company, Alpha Brewing. We did a lot of business with them. We do a lot of business with them. He was the director of engineering. They sell craft brew houses to these craft breweries, right? And we got an order from them earlier this week for a number of pumps going on to new brew houses. And I thought that was one of the things that were for sure going to dry up, with all this COVID-19 stuff. But people are still building brew houses. It's absolutely incredible to me how the craft brewers have endured. James, not to air too much of his dirty laundry, he was spending a whole bunch of money last year trying to open a tap room. And now this year he was just trying to survive. And I was talking to him, he and I are friends. He said he's actually more profitable this year than he was last year. He goes, since the first time I ran the business, I'm actually making money. So it's really interesting times, really interesting change of pace, I think, for a lot of different folks. And that being said, I guess, Leon, I want to thank you for joining us. We're going to be talking about the CCT heat exchanger testing module that you guys have. So without further ado, I'll turn it over to you.
All right, thanks, Andy. But just wanted to share a little bit with everybody else if you're just joining. Andy invited me to this party and said I had to drink a beer. Most of you guys are on a little bit different time zone than us, so but it's 5 o'clock somewhere, right? So what I got is the Fremont IPA. This is a new IPA. It's pretty good. I've never had it before, but if you ever been in Seattle, there's the Fremont Troll. This is in the Fremont area. This is under one of the highways under there. So it's one of the iconic places to visit here in Seattle.
Nice.
Anyways, we'll talk about the heat exchangers testing. So a little bit about us real quick. Thermaline, we manufacture plate and frame heat exchangers, tubular heat exchangers, and we also do shell and tube heat exchangers. We have We have a full biopharma heat exchanger line that we do shell and tubes, electropolished and double tube sheet and stuff like that. Thermaline's been around for about 30 years. We're located in Auburn, Washington, just 20 minutes south of the Fremont Troll. So all of our, this is a couple shots around our facility there. So we're in a 50,000 square foot facility in Auburn. Everything we make at our plant, including the CCT tester that we'll be talking about here in a minute. So that's what we're here for. We had a little presentation on heat exchanger testing. So today we're going to go through what you need to do, when you need to test, cover why you need to test, and then we're going to talk a little bit about what are we testing for, different types of testing. Then we're also going to talk about how you can test the heat exchanger yourself without having a third party come in. So just a quick 10,000 foot view of heat exchangers themselves. If you are joining us and actually listen to this webinar, we're going to assume that you know what a heat exchanger is. But heat exchangers are in process industry. They're using a hot fluid to exchange heat with a cold fluid. They're done through some type of barrier, so the fluids don't mix. In a plate heat exchanger, your plate is the barrier, and then in a tubular heat exchanger, the tube's actually a barrier. And then some of them will use a gasket or elastomer between the plates and the tubes. That's about all we're going to get into as far as heat exchangers, the technical side of heat exchangers goes. But just as all equipment, you have to have some type of maintenance, right? I mean, nothing lasts forever, especially heat exchangers. They're usually in a pretty tough environment. So any other equipment that you have in your plant, you have predictive maintenance, and then you have oh shit maintenance. Predictive preventive maintenance, you have controlled costs, and then your oh shit maintenance is out of control costs. So you want to try to get things under control before you actually have a problem, right? So schedule inspections, schedule tear down and replacement of components. So I try to answer the $1 million question, but I'm probably not going to get $1 million because I don't have the answer to the question. We get asked this all the time: is how long in my heat exchanger do the gaskets last? Well, that's all. Or how long do the plates last? I mean, that's pretty much all process specific, right? I mean, time, temperature, concentration. There's the heating section in an HTST might last quarter as long as the cooling section in an HTST. The other thing is material selection and compatibilities. I mean, you got to get that right off the bat. I mean, if you're dealing with some corrosive materials and you're expecting some type of stainless steels to combat corrosive materials, that's not going to go well.
Leon, let me ask you, I'm sorry, I was thinking materials, and I immediately thought Ken, who I did the webinar with last week, because that was something that we spent a lot of time talking about. But in terms of the current environment, no shit maintenance, are you seeing an uptick in that as people maybe don't have as much maintenance staff? Is that something that's changing for you that you're trying to prepare people for or trying to prepare yourselves for?
Well, I think right now what we're seeing is a lot of these plants are locking themselves in their four walls, not allowing. We had on the onset of this virus mess, our maintenance crew had we were scheduled out for months. Then everybody pulled the plug on that. A couple things are happening, right? A lot of these food plants had to shift gears from from food service to domestic production. So we see a lot of it's starting to slowly pick up, but I think a lot of these plants are running 24/7, and they just couldn't afford to do their preventive maintenance as they had scheduled. So eventually they're going to have to come around, but just the shift in the product cycle is crazy. So
yeah, absolutely.
Yeah. So
that's interesting. So it sounds like there's a lot of oh shit maintenance coming.
Yeah, there could be. I mean, if we're looking the crystal ball, yeah, I mean, if they're bypassing the scheduled maintenance just to keep running, but we all know how long that. So, but it's picking back up for us. I mean, they're loosening it up, and guys are traveling again and doing some jobs. So,
Yep.
so but yeah, so if we look at the heat exchangers themselves on the maintenance side of things, here's a little paragraph out of 3A's suggested recommendations for heat exchangers. So basically, 3A, FDA, any of the regulatory agencies are going to give some general guidelines, so they're not going to be very specific about it. So you want to check, turn on your heat exchanger, check internal defects, check for external defects, basic equipment maintenance, right? So, but the heat exchangers were for external leaks. Those are pretty self-evident. An external leak is going to be leaking, to atmosphere. You're going to see that on the ground. As you can see in a couple graphics on the rights there, the plate heat exchangers, the gaskets will have leak detects. So if a gasket would leak from one side to the other, it's actually going to leak to atmosphere and not go into the other product zone. This upper diagram, you can see a exploded view of a typical tubular heat exchanger, where if we had one of the elastomers fail there, it's going to leak to atmosphere, and you're going to see it on the ground. So it's pretty simple to see external leaks and to address those when they happen. But again, if you have a good predictive maintenance plan in place, you would establish how long your gaskets potentially would last. And of course, it takes some time to do that, because when you put a heat exchanger in for the first time, you can't establish that until you have some history behind it, right? Mm-hmm. And predictive maintenance, and you're going to change those gaskets, before they fail, right? So, mm-hmm. But what happens if we have one of the barriers fail? So the barriers, which is the plate or the tube, if one of those were to fail internally, well, we get cross-contamination. Cross-contamination is we get one of the fluids on one side that we're trying not to mix with the other fluid, they could potentially mix, right? So, so cross-contamination could be whatever is in your glycol stream could get into your product stream. If you have a hot water loop, whatever your hot water loop water could get into your product stream there. So most systems, as you know, Andy, you design a lot of systems, you're going to have pressure differentials, right? You're going to, if you're in a PMO system, the dairy side of things, they're going to require pressure differentials in your PLC and maintain a higher pressure on one side than the other side. So the idea behind pressure differentials is if you did have a failure in one of those barriers, that the critical side would push into the non-critical side. So this can be done in several ways. There's natural pressure differentials where you're running higher viscosity products or something on one side, and they maintain a higher pressure than the other side. There's mechanical ways to do pressure differentials, meaning that you put some back pressure restriction on the product side. Again, kind of the same idea. Then the controlled way, which you're actually controlling the pressures with PLC, all the controls and the valves. You're typically keeping your pasteurized regen on higher than the raw. So if you're not on the media side and you're on the regen side, so you want to maintain the pasteurized side higher than the raw side, right? So if it was a failure inside there, the pasteurized would leak into the raw side.
Now, so that's to the mechanical side to prevent cross-contamination. And this is where I'm going to show my ignorance. I remember we were doing a scrape surface heat exchanger application with a customer actually in Alaska who was processing fish guts, basically, right? They were extracting the omega-3 fatty acids. And they were having a terrible time with fouling and some of the heat transfer. So they actually wanted us the vendor who made the heat exchangers, it was not Thermaline, maybe that was why we were having a problem in the first place. But they wanted us to increase the back pressure on the product side. They wanted us to increase basically the tube pressure. Is from a thermodynamic standpoint, do those pressure differentials have a big impact? People talk a lot about balancing systems, having balanced systems. What does that mean for pressures? Can you speak to that at all? I don't really know. I just pretend like I do.
Well, when you're designing a heat exchanger, I mean, pressure, velocity, heat transfer, they all go hand in hand. You know, that's on the design side, but on the system side, yeah, if you increase pressure, as long as you're not decreasing flow, if you're just maintaining the same flow, you really wouldn't have an effect on the heat transfer itself. So, but typically in the heat exchanger world, when you're naturally without any mechanical or controlled back pressures, if the pressures are going up, then typically your velocity is different than what the original design was, but just the pressure differentials on there wouldn't cause, as long as you're maintaining the same amount of flow and the same temperature profile.
Got it.
So it's operating at a different pressure than what the other side is, right? So.
Got it. Cool.
Yeah, so we've also been asked if I do have pressure differentials, do I still need to test? And well, testing is voluntary and it's up to you, but I would like to know what product you're making, because I probably wouldn't want to consume your product if you're not doing some preventive maintenance tests. But yeah, you should still test your heat exchangers. One of the things that we see happen quite a bit if you're not testing is even if you have pressure differentials on like your regen section, where your pasteurized is at a higher pressure than your raw. So yes, that would continually go in a circle, right? But what happens like on your glycol side, if you have higher pressure on the glycol side than your glycol, we potentially could push your product into your glycol system, which we see time and time again. Now you potentially destroy your glycol system, your chiller, or you got a mess on your hands. You got to go clean up a bunch of syrup or fish guts out of your chiller, right? Same with the hot water side. I mean, you're sure you might maintain a higher pressure on the hot water side, but there again, you could be pushing your product into that circuit there. Then sometimes we see at rest, after you do a CIP or something, if you did have some defects internally, then at rest, that could start filtering back into one side of the heat exchanger. So what causes a defect in one of these barriers? So again, as you said, Andy, last week, if you haven't had a chance to watch Holland's last week's Happy Hour with Ken Kendall from B&E, he went quite in depth in corrosion. So a lot of good information in that one. I think you got that up on your YouTube site there, right, Andy?
Yes, we do. We have it on YouTube for anyone who's interested, absolutely, as we will with this one.
I highly recommend spending some time and watching that. It's very informative. He covers a lot on corrosion, a lot on material selection. It's kind of one of the reasons I kind of glossed over that, just because there was so much of that you guys covered last week. But so Ken also covered pitting corrosion and crevice corrosion, which kind of go hand in hand. So in a heat exchanger, what you see is a close-up view of a chevron pattern of a typical heat exchanger. So when you put a heat exchanger together, the two plates actually touch each other, right? So that's what holds the pressures within the plates. When you have two pieces of metal touch each other, that creates a crevice. So in what you're looking at is contact points in a plate that actually created a crevice. And as Ken was explaining last week, that passive layer of the stainless steel, there's no oxygen going through that crevice, and that passive layer does not get replenished. If you had a chloride attack or some aggressive product attack, it gets in that crevice and it starts eating away at the stainless. Then it's just sporadic from there where the corrosion goes. So we commonly see people think that these contact points are wear points from the stainless steel somehow moving, but that's kind of a misnomer, because they're actually, contact points they create the crevices that are susceptible to corrosion, right? So here's some more effects of corrosion in heat exchangers. Again, you can see over here, this is a contact point where this contact another plate within the plate frame heat exchanger, and this was a seal around a tubular heat exchanger that had a crevice corrosion attack where the oxygen was not replenished on the passive layer, and therefore it was susceptible to corrosion. So eventually, what happens is that it eats through, right? So how do you combat corrosion? Again, I referred to you guys last week's happy hour. There was a lot of material selection. proper cleaning of the material, keeping the stuff clean once you're CIP and all that. And then we also get asked quite a bit, the thicker plates buy you more time? And the answer is no, because once you have a crevice corrosion attack, that pitting attack, it's so sporadic and so unpredictable. Once that passive layer is gone, doesn't matter how thick that plate is, it could have a pit attack and get to that, whatever thickness of the plate. So thicker plates don't necessarily buy you more time. So other sources of cross-contamination, there's mechanical wear. As you can see the picture on the right there, something wore through that tube. Tube-to-tube sheet joints. So in the biopharma industry, they separate the tube-to-tube sheet joints because the tube-to-tube sheet joint is, which is this area right here, they have a heat-affected zone from the weld there. So that's another spot that's commonly fails. Weld failures inside of a heat exchanger, another source of cross-contamination. Stress corrosion, galvanic corrosion, and metal fatigue.
So that's a question I've always had. I know I need to use it, but what is a double tube sheet design on a shell and tube heat exchanger? What does that refer to, Leon?
That's a good question. So on the next slide.
Oh, there we go.
Heat exchangers with added protection. I was reading your mind there. So there
I've never seen this presentation before. It just so happened to this way. Incredible.
Right. So a double tube sheet design. So there's the upper two pictures. There's two ways to do a double tube sheet. So in our BPE line, as you can see that graphic up in the upper right, there's actually two tube sheets, and you can see this leak path here. And so what we'll do is we have a hydro swedger, so we pneumatically swedge the tube-to-tube sheet joint. So that swedger goes into this first tube sheet, and we swedge that tube sheet, and then we swedge the second tube sheet, and then we seal weld that on the outside. So if you had a leak on the shell side, it'll leak through here, and then it'll be visible, it'll leak to atmosphere, just as if you had an elastomer leak, right? And if you had a leak on the other side, then it's going to be visible to atmosphere. So, and this is another way to separate the tube-to-tube sheet, the double tube sheet, right? So this particular heat exchanger you're looking at here on the left here is one of our 20-foot long multi-tubes. So this is more of a process style heat exchanger, similar concept. This makes the tubes very visible, where this one here, you're just relying on the leak path. So again, there's no right or wrong, there's just two different ways to do it. But the same thing here, we would reach inside here and we would swedge this joint and then swedge this joint and weld here. So as you can see, if one side or the other would leak, it would leak to atmosphere. It doesn't guarantee that you wouldn't have a tube failure that could cross-contaminate, right? Then plate heat exchangers, these are mix-proof double wall plates. And the idea between mix-proof double wall plates is you stack two plates together and you either weld the port or gasket the port. And so if one side had a crack or a pinhole, that would leak to atmosphere versus going cross-contaminating. Of course, when we stack two plates, your efficiency goes down. Then the cost of the heat exchanger is obviously going to go up. We do caution on the double wall plates there that high viscosity products or anything with particles and particulates is not a good solution. But we have definitely seen an uptick in demand for double wall plates. So that defect that we're looking at, any from a corrosion or what are we measuring, right? So typically in the heat exchanger world, we're testing for corrosion or pits in microns, 1 millionth of a meter, right? Just to give you an idea of what a micron is, you can see on this chart here that the big circle represents, the diameter of a human hair. Andy, you got any of those up there left?
No, none of them left. Not very, very precious few. The barber told me I should have to pay him to find them.
Right. Okay. So all the way down to 5/10 or half of a micron, the size of a bacteria. So you kind of get a visual all of the spectrum from 150 micron, if that was your human hair, all the way down to half a micron there. And then they say that the human eye can only see approximately 50 micron, but if you notice the monocle there, the monoclan superhuman eye, I could see all the way down to 10. So
There you go.
and just to answer your question, yes, it is real. I wear it every day.
Really?
Yeah, I got, yeah, it's a long story. Might have another beer after this to tell you, but
Yeah.
it was either that or I sit here with my reading glasses at a 45-degree angle. I did that
Yeah,
for
my wife actually has the same thing. It's interesting. Yeah.
yeah, go to the monocle store, get a monocle. It works. So anyways, moving on. So to give you an idea, we put this together, the leakage rate at 50 PSI. If you had a delta P pressure differential on one side to the other of 50 PSI. So if you had a 25 micron defect, in about the course of a day, on an average 8-hour day processing, you could have, about a pint of beer go from one side of the heat exchanger to the other. But as you can see, it progressively gets worse. 50 micron defect with that same 50 PSI delta T, you get 5 pints of beer crossing from one side to the other. And then a 100 micron defect in that same hour day, we wasted a lot of beer.
Wow.
So here's a little chart, gives you a little bit more information, right? So 10 micron, again, if you think back to that little graph, how small a micron is when we're talking micron. 10 micron at 10 PSI, you're going to leak 1 gallon per work year, all the way up to 400 micron, could be 4,000 gallons, right? So just kind of puts things into perspective there a little bit, what could be passing from one side of the heat exchanger to the other, right?
Wow, this is a really incredible chart. Wow.
Yeah, they go back there. So, yeah.
Go ahead.
Yeah, no. What, you got a question?
No, I was just going to say that I'll make sure to get this presentation from you, and anyone who's viewing will make it available, just the slides, so you don't have to rewatch the whole thing, because it's really incredible how much a small hole with a pretty small differential pressure, how much you can lose over a period of time. It's really, really something.
Yeah, and especially if you look at the micron size and how exponentially it grows, right? So
right, yeah.
So then so how do we test for all these small defects inside of a heat exchanger? You can't see inside there, right? So somehow we have to test inside there to see what's going on. I guess one way to test is we can have a product recall. That's probably not the right way to test, right? Or as we mentioned before, you could get a bunch of fish guts or milk in your chiller. So those are a couple ways to test, but probably not the right way to test. Right? So first of all, at Thermaline, we classify testing into 2 categories. We say a primary test, and then we have a secondary test. So a primary test is when we test a group of plates or tubes as a component, as a whole. Where a secondary test, we're trying to locate the defect. So if we test a tubular heat exchanger, like we showed in that previous picture there, and we do not sense anything, there's no sense to do an individual tube test, right? You could pass go and you can go right back into production. Same with the plate heat exchanger. You could test a section on the plate heat exchanger, let's say if it had 100 plates in there. But if you don't sense a defect within those 100 plates, there's really no reason to go test each plate individually. But if you do sense a defect in the primary test, then we're going to take a secondary test and we're going to locate that defect. So again, it's important to know the difference between a primary test and a secondary test. So there's several methods out in the industry right now for testing. 3A, FDA, the Canadian food agencies, all those agencies are not going to endorse any one test. They just recommend that you test using a test that's qualified. So there's different test methods for primary testing that are out there. There's helium testing, which you're charging one side of a heat exchanger with compressed helium gas. Then you use a helium sniffer on the other side to sense the helium coming through the plate, through the defect. We call this a pressure and hold test. I've seen some plants try to mock this test up and do it themselves. So they'll pressurize one side of a heat exchanger, put a sensitive gauge on there, and then they try to to hold for a predetermined time, and if the gauge drops off at all, then the assumption is there's a problem. As you can see, that test has some quite a few different issues, especially if you have any type of microscopic external leak that you can't contain. You don't know what's bleeding out the pressure. There's a company out there that does fluid measuring tests. So they're charging one side up with a fluid and then trying to measure fluid coming out the other side. Conductivity testing, and then there's the patented CCT hydropneumatic test, which is our test. We'll get into that in a little bit. Then secondary test methods, which are also used as primary test methods for some. Probably the most well-known out there is a dye test, where you're actually using a non-destructive dye, and then you're spraying one side of the plate and looking for cracks or pinholes in the other. So again, you can see that's why we classify that as a secondary test method. So if we pass the primary test method, there's no reason to go back and do a dye test, because we've already passed the primary test method. We don't have a problem. We did have a problem, that we would use the dye test as a secondary method to find the problem. So we'll
why don't you think that that's more regulated? Why don't you think there is a standard testing method that 3A or the FDA or USDA, especially at least when we look at sort of regulations and different, I mean, dairies are some of the most regulated bodies that there are, between PMO and everything else. Why don't you think they're more specific with test methods required?
Well, they just require a test that is qualified. So they don't want to stifle innovation either, right? So if you, and then also, as well as you know as well as I do, that you could lobby for any one test, and then whoever does the best lobbying to get their test passed, wins that game. So yeah, I'm just saying, any of the tests that I mentioned before are working tests. If you there's different ways to skin the cat, right? So if you have a test that you've developed and it works, there's no reason to tell the other guy he can't use his test that also works, right?
Got it.
And that's what was explained to me, because I actually pursued some input from the FDA, and they said, well, we can't and we will not endorse any one test, because again, you don't want to stifle any innovations either, too. So
yeah, that makes sense.
Yeah, if you've been involved in some of these standard writings committee meetings, they're kind of leaning towards whoever has the most involvement as far as manufacturers and stuff, right? So
right.
All these standards are written,
So
yeah. So the dye testing again is the most well-known out there, and it's performed, again, a lot of times used as a primary test, which you could do, which we still have customers that request it as a primary test. I think dye testing is kind of becomes like a trade name for testing, because people think that if I say I need a heat exchanger test, that automatically defaults to dye testing. Again, but there's all kinds of tests that do function and work, and the choice is up to them. But we do that. We do dye testing, and then again, it's a secondary test for us. But I've done it for its primary test. But as you can see in the picture there, it's quite extensive, right? You have to remove the plates, clean the plates, then you're spraying a dye and a developer, then you're inspecting every plate. It's good to locate defects, but it's time consuming, it becomes expensive. There are other ways to do a dye test. We could circulate the dye within the heat exchangers, but you still have a crew on site, pumps, tanks, and you recirculate a dye in one side of the heat exchanger, flush it out, and then you can open the heat exchanger and inspect it. A lot better to do on site that way versus trying to do individual plates. Both methods are done. But again, it's time consuming, and it takes a bit of effort to do the dye test.
How many plates are in like a typical heat exchanger? Like the picture on this slide, like how many plates are in that unit?
It all depends. I mean, plates can range anywhere from a half a square foot of surface area up to big plates. I mean, there's huge plates out there. The amount of plates that are in some of these, especially when you get into the industrial side of things, they got this big huge plates, and there's hundreds of plates in there. So just the combined surface area, if you were to lay all these plates out at some of these units, is thousands of square feet that you're testing, right? So
Wow. You have to coat those. Yeah, that's incredible.
yeah. So we'll just dive right into the Thermaline hydropneumatic tester. This is our primary test system. CCT stands for cross-contamination tester. It's the only primary test system on the market today that's commercially available. It's meaning that we sell this as a kit, sit on the shelf, and if your the maintenance personnel needed a test, they're able to grab this off the shelf and do the test. As soon as you can see the picture there, the kit comes with all the components needed to perform a primary hydropneumatic test. So the benefits of testing in-house. Well, one of the things that come up with some of this stuff that's going on today, as Andy and I were talking about earlier, is a lot of the plants are doing less visitation. I mean, the visitation protocol has changed quite a bit. They're limiting the amount of people for obvious reasons coming in and out of the plant. So that's a big benefit of being able to test in-house. If you had the tester on your shelf, minimizes the plant visitors. The other obvious reason to test is it saves thousands of dollars. I mean, if you're if you're having a service provider come in, set up any one of those tests that we just explained, it takes time, and the CCT test is simple, it's straightforward, it's pretty easy to do, so it saves thousands of dollars. Improves quality assurance. You have the tester available 24/7 at your plant. A lot of these plants that we work with, they're waiting for scheduling, whatever else. So if you suspect a problem, you can just grab it off the shelf and then test, right? So why wait 365 days between tests? That's what 3A recommendations were once a year. So if you're with the new FSMA regulations and all that coming down, I mean, if you read in between the lines, the Food Safety Modernization Act, it's all about being proactive and identifying a problem before you have a problem, right? And then the CCT tester to test all makes and models, right? Tubular, APV, Alpha, Thermaline, any maker model test. So how does it work? Again, we call it a hydropneumatic tester. The concept is pretty simple and basic, but it's very effective. So again, we talked about the heat exchanger. Heat exchanger has a barrier to keep the fluids from mixing. That's what we're testing for, is a defect in one of those barriers. So what we do is we pressurize, each heat exchanger is going to have two circuits, right? We pressurize one circuit, and then if air, we pressurize it, we use a plant air. If air was to pass from one side to the other, it's going to travel to the ambient circuit. And then once, we call this a quick test. The CCT has two modes of quick test, where if air passes one side to the other, you can see it'll just bubble over here. It's a visual test. Then we have a PM test, where air passing the other side is caught here, and then we could calculate as it moves the water column. We'll get in that test here in a second. So first, we'll just the kit requires 120 volt power supply and compressed air, which almost every plant has both, right?
Yep.
It's pretty simple to hook up. We got to cool the heat exchanger down, remove the pipes, and then drain the heat exchanger. So here's a quick graphic of installing the CCT tester. The kit comes with everything you see except for the air compressor. You have a preset regulator dump valve that goes on circuit A, which is the red circuit of the heat exchanger. And then the CCT driver over here connects to the opposite side of that circuit. So the CCT driver senses that you're pressurized that circuit, right? And then the tool itself connects to the opposite circuit, which is the blue. And then we cap the other side. So that's the ambient side, and then this becomes the pressure side, right? And then from there, we take the 90 milliliter little beaker, we fill it up with fluid, and then the quick test mode, without even turning the CCT on, you'll see a bubble. I mean, it's pretty straightforward. So we have air passing from the pressurized circuit into the ambient circuit, and we capture that through that down tube into the water column. Then you can see a bubble. So I would say 99% of the times when we test a heat exchanger, that we sense it right away with this visual test. Again, this is just a visual indicator if I have a problem. And so the CCT has a PM mode, which is our preventive maintenance mode. The PM mode of this is a time-based test, and this is what creates your documentation. So you want to have some documentation for your records on when you tested, if it passed or failed the primary test. So that's what the PM mode does. So the PM mode is a time-based test. So it's time and volume. Again, the same graphic. If we have a defect in one of the barriers, the air molecules are going to pass through that defect. Instead of going into the CCT as a bubble, the chamber closes here. It goes in, the air accumulates, and now what we're doing is we're pushing this water column up, right? And as we're pushing the water column up, the clock's ticking, and we could figure out, you know, the size of the defect based on the math of the calculations there. So then I get asked quite a bit. It's like, well, if I have a defect, you know, why do I need to know the size? That's irrelevant. Well, we would have to argue at that point, because knowing the size of the defect, you know, gives you the ability to make an informed decision on what to do about that defect. The fact that you did a preventive maintenance test on that specific day doesn't mean that that defect developed that specific day. That defect could have been growing over the course of the last 2 weeks, month, whatever, prior to from the last time you tested. And if you have a small defect, right, you might want to just wait and schedule that to your next, you know, shutdown when you could change that plate out. Or if you know that you have a large defect, you're like, oh, I've got to do something now. So then that kind of changes your approach on how you schedule to cure that defect, right? So I think from our philosophy, it's very important to know the severity of the defect. So on the PM, go ahead.
This is a quantitative test method. Are any of the other test methods you talked about quantitative, or are they mostly qualitative, observation-based?
They're quantitative, and a dye test is observation-based, right?
Yep.
The helium test is, I guess, more quantitative. It's a pass or fail. So you either sense helium or you don't.
Yep.
Yeah, the other ones where you're measuring fluid, you know, you saying it's quantitative. So again, going back to your other question, there's, you know, different ways to test heat exchangers. This is just simple, basic, comes in a little suitcase, and it's operator friendly, and anybody can use it, right? So
here's a question. Here's a question from Jim Boo. He says, "How do you know if air is leaking through a plate or out through a gasket?" He also adds, "Did I miss something?"
Well, yeah, the part that he missed was we've already done an external leak inspection. So
okay.
when we do pressurize one side, the regulator maintains pressurized in the pressurized circuit. The ambient circuit, if you have a leak big enough that you're gonna leak, you know, a quarter PSI, then you have a big problem. It's very visible before you even started your test, right?
Right.
So, but yeah, moving on. So if we do the PM test, you enter the serial number, and then whatever section you're testing, you test metric material units. Then we got to know the size of the heat exchanger, again, because this is volume and time-based test, right? So a larger heat exchanger, we're going to test for a longer time. Smaller heat exchanger is going to test for less time. So it's just like this box here, right? If I had a box on the left, is 1,000 times smaller than the box on the right. Well, if I put two air compressors, turn them on at the same time, the box on the right is going to take 1,000 times, much longer time to get to 1 PSI than the box on the left. So we got to know that information before we can do an accurate preventive maintenance test. Again, if we look back at what the 3A suggested practices are, is that they also recognize that it should be volume based, because there is a correlation between the size of the heat exchanger and the test. So for the volume side, we either know the volume of the heat exchanger on the left, if you know it, if it's on your drawing, your schematic there, you could just input the volume of the heat exchanger. If you don't know it, we could go to the screen on the right, and that's where we're putting in the dimensions, just the rough dimensions. We're going to get it within plus or minus 10% of the volume of the heat exchanger. Again, the increments of the calculations are based on, you know, some incremental step ups of the volume there. So length times width times height. Then the CCT calculates the volume, and then we press go. And when we press go, you can see that the air passing through no longer is a bubble, and the camera is now has been sped up. This demonstration here. And then obviously we're looping the video here too. So, but as the air passes from the pressurized circuit to the ambient circuit, it's going into that chamber and it's moving the water column. The water column is now counting until it hits the sensor. It says, okay, you failed. So what you see on the screen is that the test failed. It gives you the elapsed time. It said, okay, for the volume that we put in there, you were supposed to test for 5 minutes. The elapsed time was 1 minute 45 seconds. Again, we sped up that camera there for this presentation. So that actually took 1 minute 45 for that thing to fail. And then, let me back up one. So on the back of the driver, the CCT driver, there's a USB port where you take the thumb drive. Too many. So you take the thumb drive out. It uploads to the cloud, and then you download your PDF of your test results. So it has your serial number, when you tested, any notes that you put in there, any specific identifications for that. So it provides the documentation that you've tested and when you tested.
Wow.
So yes, we also, it could be used on tubular heat exchangers, shell and tube heat exchangers, multi-tubes, all types of heat exchangers. Just any process heat exchangers that are fluid by fluid, you can use the CCT on.
So I can use this on a scrape surface. This actually gets back to a question that Ken had. What's the most common heat exchanger that you see? Is it shell and tube, plate and frame, scrape surface? What do you see most often, and what applications do you see each of the heat exchangers used specifically?
Well, for our industry, I mean, 50% of what we manufacture is plate and frame heat exchangers here. So that's by far one of the largest product groups that we have. As far as testing and service goes, there again, it's plate and frame heat exchangers are the most of what we see that we test. Just because everybody, if you're going to process something, your first choice is plate and frame heat exchangers because of cost, footprint, yep, and all those things, right? So by far the most popular heat exchanger type in processing is going to be a plate and frame heat exchanger. And then again, they're also the most susceptible to internal defects because of the 1,000 contact points and all the things that we talk about, corrosion.
Yep.
And then, so testing, it seems, I would say 90+% of what we do and what we sell the CCT for is for plate and frame heat exchangers. It's simply because most of the shell and tube heat exchangers are more in the food and beverage, not so much in pharma. Pharma, they recognize tube heat exchangers for processing. They don't recognize plate and frames. So we get into different industries, that ratio flips completely. So industry specific, and then kind of equipment specific too. So what we see a lot of times in the food and beverage is shell and tube heat exchangers used for utility side of things, right? Steam by water, hot water loop, where they're really not that concerned about cross-contamination. We do test utility heat exchangers, but usually by that time, they've been stuck in the corner and pretty much have self-destructed and are done, right? So, but moving on, so if you do, like the test that we just showed, it failed, you failed the test, so now what do you do? Again, so if you fail the test, then you're gonna move into a secondary test where you're gonna locate the defect. There's a couple ways to do the secondary test, as we showed in the previous slides, that we do a dye test, or we do a flooded dye test where we're actually pumping, circulating a dye. But with the CCT, you have the ability to do what we call an elimination, or process elimination test. And we do this a lot on like large HTSTs. If you're looking at 300 plates in a regen section and you do sense a problem, that's a lot of dye testing. What we've developed with the elimination test, you need a spare plate to do this, but you could open the heat exchanger up and then put a block plate in the middle of those 300 plates, retest one side, then retest the other side. So if you retest the one side and you don't sense a problem, well, you've just narrowed your workload down to 150 plates. You do that again and you narrow it down to 75 plates, and then on down and you get to the last 5 or 10 plates. So that really speeds things up if you're in a situation where you can do that. So that's another huge advantage to using the CCT. So not only do we use it as a primary tester, we use it for the elimination test as a secondary tester. But what we normally find, as you see in those pictures on that the plate, is that it's not usually one plate that goes. The rest of the 299 plates aren't too far behind it. So,
right.
so typically, if you have a crevice corrosion attack, you're going to find a pretty large percentage of the plates are going to be, following suit and failing pretty quickly. We do a service where we clean and regasket or recondition plates, but they're still, if they have any of those pit marks, then that passive layer is gone and they're on their way out. So we also have what we call the CCT 2.0. So the one the presentation was about the CCT 4.0. The difference, they both act the same, function the same, they kind of look the same. This is a manual tester. It's just a more economical version. You're able to do the quick test, but it's a manually timed test. So it comes with a chart. I didn't get a chance to fill in the chart here, but you look up you calculate your own holdup volume, and then the chart tells you how long you test. So you got to use a stopwatch. So, but that's available. It's a more economical tool than the 4.0, but we have both versions available. And then we provide support, right? So we provide the secondary testing support. So if the plant opted to have the tool on their shelf and they did the primary test and they said, "Oh, we have a problem," we could help locate the needle in the haystack. We also provide CCT testing as a service still. So not only do we sell the tool itself, we also provide it as a service. Maybe you want third-party verification or what, and then we do on-site and then off-site cleaning and regasketing and such. So, there again, there's the two models. Both come as a kit. They have all the connections, 1 to 3 inch sanitary connections. The standard we could beyond that we make all kinds of custom fittings to fit up to the tool. There's I-line fittings, S-line, larger fittings. And this is just what the basic kit comes with.
Yep.
So, anyways, that's it. So, there's a little special through May. Contact Andy to get more details on it.
There we go. Yeah.
Yeah.
How do you see this? How do you see this go most often? Leon, we have distributors, end users alike. I mean, are you seeing your distributors providing this as a service? Are you working with end users to implement it as part of a preventative maintenance program? How does it go? How does it go most often?
Well, the CCT we developed a few years back. And then we kind of marched behind everybody else saying, okay, let's provide the service. Let's not sell this valuable tool to the end user. Let's just hold this, close to ourselves and provide the service. But what we found is, to answer your question a few minutes ago, there's many methods to test a heat exchanger, and they all work, right? And so when a new method comes in, you're still doing the same thing. You're still doing a comprehensive test. So there's not a lot of incentive for an end user that has had a relationship and a developed preventive maintenance plan, before you even got there, right? So we recognize the value of every food plant in America should have this test kit at their fingertips at any time. And so since we released it to end users late last year, we've had a tremendously good response. So yes, the distributors should have the test kit, at their disposal too, to provide that third-party verification or to provide the service. And so it's really, there's no one size fits all. We have a lot of end users that are recognizing the value of this. I mean, Leprino, the big cheese plants, all their plants have CCT testing. Other large plants that are moving towards this. Doesn't mean that you have to abandon anything that you've done in the past. Just simply having a test tool on your shelf that in an instant you could test for any problems.
Yeah. How much time do you think people save using the elimination test? I'm curious. How much time are you able to shave
Days.
off just by? Yeah, I mean, it's got to be just incredible, right?
Days. Yeah. Again, there's a little bit of trick to doing it. It's just not, you know, if you had an automated heat exchanger where it's push button, then it's a no-brainer, right? You know, opening and closing a tie bolted style plate and frame heat exchanger is no simple task either. So we do an elimination test. Let's say if we were to send our crew out to support somebody that sensed the problem in that HTST, we go out. We have special equipment that we use to open and close the heat exchanger. So for us to do an elimination test, it's pretty simple. You know, for somebody else to do the elimination test that doesn't have that specialty equipment, and you're trying to open a big tie bolted heat exchanger, well, you're probably going to be pretty pissed off at me if you have to open that thing 4 times, right? So yeah. So that's where I'm a little bit hesitant. But you know, once you understand the concept and in the right conditions, the elimination test saves days and days of time. Yes.
Do you typically provide, when you provide replacement plates, do you provide them as individual plates, or do you provide like a plate pack? Is there you mentioned that if one plate failed, the rest probably aren't far behind. Is there like a best practice for servicing these units, for replacing the plates?
Yeah, that statement that one plate fails, the others aren't too far behind. That's why we explained all the other potential ways that a defect may arise. You may have a crack in one plate, and the other plates might be fine, where you only need one plate. So yeah, we sell individual plates, you know, whatever the customer needs. You know, when you get into a crevice corrosion attack, which normally is what we see as the biggest culprit to a failure in a plate, then yeah, most of the other plates are not too far behind. But it is interesting to see if you do open a heat exchanger and you're looking at the plates, because it's time, temperature, and concentration that's going to create the corrosion, right? So sometimes you could look inside of let's say a regen, the hot regen coming back, the first plate is going to be the worst, the next plate, that first plate it touches is going to be the worst, and it progressively gets better. So maybe 50% away through that plate pack, the plates are unaffected by crevice corrosion. So there's no one size fits all to that statement. You know, I mean, it's about knowing what you're looking for and you know, taking the best approach to the situation. So.
How often would you say? All right, so let's say that we have a customer that we do an annual preventative maintenance for, and as part of that annual preventative maintenance, one of the things we do is we change out all the diaphragms on their diaphragm valves. We change out a lot of seats on their angle seat valves, and then we tear apart their shell and tube heat exchanger. This is a pharmaceutical facility it's on their WFI loop. We pull out their 2 shell and tube heat exchangers and replace all the gaskets, but we don't test the tubes because, you know, it seems like there's no issue. How often do you get people who are maybe surprised to find that they have a leak in one of their plates or a hole in a tube bundle or something like that? Does that happen often?
Well, there's a couple things to that question. I mean, the most end users are going to know let's just say that the process has been around a while. It's not a new process. They already understand that, you know, their plate life is going to be 5 years. The gasket life is going to be 5 years or whatever. You know, within that time frame, they could probably pretty well predict that they're pushing up against the end of that expected life expectancy. So a lot of times, most of them aren't too surprised, I would say.
Right.
You know, again, it's all about predictive maintenance. You know, trying to get on top of it before you do have a problem, right? So it's just assurance, like that scenario that you're talking about. If you were to CCT test those tubular heat exchangers, it's just one more, you know, assurance that nothing's happening, because in the pharma world, you know, in those shell and tubes that you're talking about, you do have, you know, stainless steel baffles that are rubbing on those tubes. So the tubes themselves may be very robust, you know, and not susceptible to just a crevice corrosion attack as a plate would be, but they are susceptible to a mechanical wear
Sure.
And whatever else. So you may end up, and then there also could be, depending on what's on the shell side, there could be, crevices between that the baffle and the tube itself. So again, maybe the tube itself is, robust, thick, not going to split, but there's other things at work, that could potentially, I'm sure these heat exchangers that you're talking about are double tube sheet, but there again, it's just one more step in your, providing the, a service to that company, that assurance that the internal workings of the heat exchanger are still functioning properly.
I mean, I know this is used mostly on plate and frame, but I can't help but think that for the pharmaceutical guys, I mean, having a way to prove, a report that says, no, we tested it and my tube bundle is intact, I mean, I would imagine that would be something they almost have to have and have on a some sort of regular basis.
Yes, we've got a lot of interest. We're working with a couple of pharmaceutical companies in the back east that are looking to move this direction, just to implement a. Yeah, sure. We all have. They all have the double tube sheet design. They have the safety, barriers to take into consideration a tube sheet failure, and all those things I just mentioned about what happens on the shell side. So we're working with a couple companies to implement the CCT into their preventive maintenance schedule.
Last question I'll ask, because we're just about out of time here, and this is going to, well, actually, this is not the last question, but this one's kind of off the wall. One of the things that we've seen a lot of recently, and I acknowledge this might not be in your area of expertise, is single-use technologies. We've seen some single-use heat exchangers, but the way that this strikes me is it's essentially an integrity test of sorts. Has anyone ever asked you if you could use this on like a single-use system to see if you can test for leaks in those types of systems?
So the single-use systems that I've seen are where they're actually, like, are you talking the clamshell systems and the biopharma where they're
Exactly. Yeah, clamshell type systems, hoses. You have a lot of different joints. I'll give you an example, and not to maybe air too much of our dirty laundry, but we do some assemblies for a company that go into a peristaltic pump, and for whatever reason they were getting failure, and we couldn't pinpoint why or where exactly those failures were coming from. And I can't help but think that maybe having a device like this or some sort of simple integrity test might help some of those users identify, I guess, not only identify where issues are coming from, but ensure there wouldn't be an issue before they run a valuable product through their system. Maybe we can, it's an interesting idea. Maybe it's something we can talk about more offline, but
I'd be interested to learn more. I couldn't really speak, I've kind of followed you, but I would really need to kind of drill down on what exactly.
Yeah, we can talk about that.
On the exact situation. So
yeah.
I'd be happy to talk about it further.
Absolutely. All right. Well, then the last question is, how was the beer? What's your review?
It's pretty good. I'm liking it. I got another 5 of these downstairs in the fridge, and I think it's Friday afternoon. Even though you guys are 2 hours ahead of us, so you've overstayed your welcome. I think I might well just call it quits for the day. Get out of here.
That's not a bad idea, Leon. We appreciate your time. Thank you to everyone who attended. And if you have any questions, feel free to reach out to either of us. We'll make this presentation available on our YouTube page. And slides are available as well. So if there's anything we can help you with, please let us know. Leon, thanks again. We really appreciate the time and all the information you shared with us today.
All right. Thank you. All right.
Take care. Take it easy. Have a good weekend.
All right. You too. See ya.